An ontology is a set of concepts grouped into categories and providing knowledge about the relationships between the concepts. In the world of biomedical research, ontologies are extremely critical as they help to group related concepts on the most fundamental level. With electronic health records, ontologies help to achieve semantic interoperability by facilitating exchange of information between different standards and data sets. Here at the Department of Biomedical Informatics and Data Science, Associate Professor Dr. Amy Wang is building a resource to support research and patient care that focuses on biomedical ontologies. Here's a look at how Dr. Wang is bridging electronic health records data and research to help advance the understanding of human health.
Using patient data for research is a major challenge. The information for research is really different from the information needs used for clinical care. And patient care prioritizes efficiency, practicality, and user-friendliness. But research really needs standard and consistent information to make it suitable for computer analysis. So, when we have accurate and standard data, then it makes it much easier for people to find what they're looking for. They can make sense of it, they can trust it. It's much more useful for analysis using big data, machine learning, and artificial intelligence.
With the amount of NLP generated information that's being created, organizing it into ontologies, into normalized concepts that you can do computations on is incredibly important.
And having more accurate, precise, consistent data and data that are organized in the right way really supports all the computable things that we're doing, all the big data, the artificial intelligence, and the machine learning. And this will improve our ability to learn more about relationships between diseases, treatments, risk factors, and it'll help us improve our understanding of human health.
So there are many standards that's already been developed, but you can argue that as our language is growing, there's a significant task of classifying these languages and making it more structured.
So for example, if you take a bunch of bacteria and you try to organize it based on characteristics, which ones are similar or cause certain kinds of diseases or have certain genetic components, and then you link together different antibiotics that tend to work in the same way, then maybe that can help us find new antibiotics that might be effective for, say, a new kind of bacteria.
So her work, even in the context of today's AI, is still very efficient, is still very important, because potentially anything that she does come up with a standard can be used to pre-annotate the data and then make the machines work less harder and maybe with a smaller memory footprint, lesser energy consumed in the future application of AI.